so far as we've looked at production possibility frontiers with opportunity costs, we've been under the assumption of the law of increasing costs, where the more and more you produce of a good, the greater the cost is going to become. So we showed in an example earlier that for each additional car you made, you had to give up more and more trucks for that last one. Let's take that assumption out for a second, and let's say that the production possibility frontier is a straight line. So as you move between any 2 points, that opportunity cost, what you're giving up, is the same. The first unit of good A is going to cost you the exact same amount as the 100th unit of good A. All right, so let's go over here for a second. And let's look at General Motors and say that this is their production possibility frontier. At point A, these are the two endpoints. They're making 40 cars and no trucks. And in point B, they're making 20 trucks and no cars. All right, so we have that here. So let's look at they move from point B, right here, all to point A. So over that point, all right, from point A to point B to point A, their car production is going to go up by 40, but their truck production is going to go down by 20, because cars from point A to point B goes from 0 to 40, goes up by 40, but trucks goes from 20 down to 0. So let's look at that. So as you go from point B to point A, you're giving up 20 trucks, but you're getting 40 cars. All right, so that's getting the first part of it. So the opportunity cost, all right, so what is it costing you to get those 40 cars? Well, the opportunity cost, what you're giving up, is those 20 trucks. So the opportunity cost of 40 cars is 20 trucks. Now, keeping in mind that it's a straight line, so as you move between any 2 points, the opportunity cost is going to be the same. Let's break these down. Let's divide both the number of cars and the number of trucks by 40. Well, if you do that, what you find, if you divide 40 divided by 40, you get 1. Divide 20 by 40, you get 1/2. So when you do this, you find that the opportunity cost of one car is 1/2 of a truck. And so for every car you want to produce, you have to give up exactly half of a truck. Okay. Now, recalling back to the marginal cost term, which was discussed in an earlier presentation, marginal cost is the additional cost of an additional unit. And so really marginal cost is the opportunity cost of one unit. And so this gives you your marginal cost. Right? So the opportunity cost of one car is half a truck. Now let's look if we go from B to A. From A to B. As we move from A to B, here to here, the number of trucks you produce goes up by 40, but your car production goes down by, trucks go up by 20, but the number of cars goes down by 40. So as you move from A to B, car goes from 40 to 0, goes down by 40. Trucks goes from 0 to 20, goes up by 20. So what is happening here is you are giving up 40 cars, but you're getting 20 trucks. So what that means then, it means that so to get those 20 trucks, you have to give up the 40 cars. So the opportunity cost of those 20 trucks is 40 cars. And if we do that same dividing by 20, if you want to get it in terms of for every truck, you find that the opportunity cost of one truck is going to be 2 cars. So for every truck you produce, you have to give up 2 cars. Right? So for General Motors in this case, for every truck they want to produce, they have to make 2 fewer cars. That's the trade-off there. Now, this may seem a little bit of a pain to kind of go through this process. There is a trick, and it's a good trick, especially when you get into a little more complex numbers. So here's the trick right here. Oops. So it goes like this. When the opportunity cost is unchanged, the opportunity cost of one unit of what is on the x-axis, whatever good it is the absolute value of the slope number of units of what's on the y-axis. So for example, let's look here. The slope here, if you do rise over run, you find that the slope equals minus 2. Right? Rise over run, if you move between any 2 points, it's the change in y divided by the change in x. So what happens is you go here, y goes down by 40, x goes up by 20. Minus 40 over positive 20, minus 2. So that's the slope. And so, going back here, slope's minus 2. The opportunity cost of one truck equals the absolute value of the slope, which is minus 2, so it's 2 cars. Right? The opportunity cost of one truck is 2 cars. Right there. Now, once you find the opportunity cost of one good, you can find the opportunity cost of the other good by its reciprocal. So if the opportunity cost of one truck is 2 cars, then the opportunity cost of one car is the reciprocal of 2, which is 1/2 of a truck. Right there. Okay. So let's look at another example here. Let's take this one. Move it over here. Oops, not sure what I just did there. Okay. So let's say then that this is actually let's go this way. Let's go out to say that this is 60. And what just happened there? Okay. So let's say this is our production possibility frontier here. And it goes from 40 to 60. And let's look at shirts and pants. Right. So now when this is the case, 40 to 60, you can see rise over run as you move from any of the 2 points. The y goes down by 40, goes up by 60, and so the slope is minus 2/3. Right. So then if we go from this, we can find that the opportunity cost of 1 unit of what's on the x-axis, one shirt, is going to be 2/3, what I have here, pants. Right. And so if you go with that same method, so then the opportunity cost of one pant, or one pair of pants, is going to be 3/2 of a shirt. Right. So it's saying for every shirt you make, you have to give up 2/3 of a pant. And vice versa. So that just takes a look at how you approach a production possibility frontier in the event that it is a straight line.